In this video, I'm going to introduce you to our CTScope software. I'm going to be covering these topics: what CTScope is and what it's used for, where to download the software, how to start the software and begin a new scope file, and how to navigate the software user interface. So if you're ready, let's get started. CTScope is a software-based multi-channel oscilloscope. This software is used to monitor the performance of our line of AC and DC variable speed and servo drives. CTScope supports the following drives: the Unidrive M family of drives, with the exception of the Unidrive M100, the Unidrive SP drive, the Commander SK drive, the Digitax family of servo drives, our HVAC drives, the H300 and the Affinity, and our DC drives, the Mentor MP and the Quantum MP. In addition to the drives I've just mentioned, CTScope also supports the PowerDrive F300 and our line of drives for the elevator industry, the E2 and E300. Basically, CTScope can be used with any of our drives that support either serial or Ethernet-based communications. Now, let's visit our website so you can see where to download CT. To download CTScope software, navigate to our website, which is found at www.controltechniques.us. I'm on the home page of our website, and the software download page can be reached by clicking on Downloads and then choosing Software. You'll need to register with us in order to download things from our website. If you haven't registered, click here. If you've already registered, just enter your email address here. Click the download link next to CTScope to download the software. The first time you open CTScope software, the software will prompt you to register it. For now, just skip that step, and let's look at what you'll need to do to create a new software oscilloscope. The startup wizard is shown here. I can elect to open an existing scope configuration or a scope trace that I've saved earlier, and I can also choose to create either a single or multi-channel scope configuration. CTScope software supports 8 analog channels and 4 digital channels. I'll choose a new multi-channel configuration. The first thing you'll see after choosing what type of scope you'd like is the multi-channel configuration page. Here, you'll choose what kind of drive you're working with by dropping down the list under Drive Configuration, Target. I'm working with the Unidrive M700 today, so I'll choose that. Next, you'll need to choose the drive's operating mode so that you'll be shown the appropriate parameters to monitor. I'm working with a drive that is set up for RFC-S or servo mode, so I'll choose that. Next, let's look at how to configure channels. For this example, I'm going to configure a scope with 2 analog and 1 digital channels. I'm going to choose to look at speed feedback on analog channel 1. This parameter is located in menu 3, so I'll expand menu 3 and choose parameter 2, which is speed feedback. On channel 2, I'm going to look at my speed reference, which in this case is an analog signal that's connected to analog input number 1 on my drive. The analog parameters are located in menu 7, so I'll expand menu 7 and then choose parameter number 1 for my second channel. I'm going to look at the state of drive input number 3 on my digital channel. That parameter is located in menu 8. I'll expand menu 8 and then choose parameter 3 from the list. I'll also make sure that I've chosen a digital channel to display this parameter. Next, let's look at how to configure communications. The communication settings are accessed by clicking on the Settings button. To begin, you must choose a communication protocol that suits the drive you're going to be monitoring. The first few options in the protocol list all pertain to our older products, such as the Unidrive SP or Unidrive Classic. The last two are the most common, and they are CT-RTU, which would be used if you're working with a drive that utilizes serial communications, such as our Unidrive M200, 300, or 400. If you're using one of those drives, and you have our CT-USB-cable and AI-485-adapter, then choose this protocol. If, like me, you're going to monitor a drive that supports Ethernet communications, then choose CT-TCP/IP. The drive I'm connecting to has an IP address of 192.168.1.100, so I won't need to make any changes to the IP address fields. If the IP address of the drive you're connecting to is different, type the drive's IP address here. Also, be sure that your computer's network adapter has a static IP address that's compatible with the network you're connecting to. I'm going to click the OK button now, and then let's have a look at the CTScope user interface to see how to start using the software to monitor the parameters I've chosen. I'm connected to my Unidrive M700 using Ethernet. While CTScope works over RS-485 too, unless you have the baud rate in the drive adjusted to one of the higher rates, the scope traces you see will tend to be choppy. I'll start the scope trace now, and you can see how the various channels appear. The top window is for the digital channels, and the lower window is for the analog channels. I can change both the sample rate and the sweep rate for the scope by adjusting these buttons. By default, the Y-axis is scaled automatically, but you can scale it manually by clicking on this button and then entering your desired scaling here. As you can see, CTScope can be used for long-term sampling too. Adjusting the max buffer size will either increase or decrease the maximum trace time. Clicking on the Triggers tab will let you automatically start and stop the scope trace by filling in start and stop times. You can also choose to trigger the scope on a specific channel. I'll change the color of the digital channel by clicking here. Next, let's see what you can do with the scope traces after you've captured them. Now that you've seen CTScope in data acquisition mode, I'll stop the scope trace so you can see some of the other tools that CTScope software provides. First, I can zoom in and out of the trace using the zoom controls. I can also add cursors to the traces to facilitate analyzing the traces. CTScope also allows you to export the scope trace data to a .csv file that can be opened in Microsoft Excel. To do that, click on File and then Save Raw Data. You can make notes regarding the scope traces by clicking on the Scope Information button like this. And finally, scope configurations can be reused by clicking on File and then Save As. Thank you for watching this video. I hope you found it informative, and if you have any questions, I can be reached at the email shown here. Please refer to the training section of our website for more information about our training courses and to see our current training schedule.